The RIDGID SeekTech ST-33Q multi-frequency line transmitter is part of the SeekTech cable and pipe locating system. The ST-33Q can energize buried utilities with an active electrical signal that can be traced with a compatible receiver, such as the SeekTech SR20. This allows the utility's location to be marked so it can be exposed for repair or avoided during excavation. The ST-33Q can energize a utility in three ways: with its direct connect leads, with its built-in coil antenna, or with the optional clamp. When inducing with its built-in antenna, the ST-33Q's design produces a signal that's 8 times stronger than competing transmitters, so you can trace up to 50% farther, even in the toughest locate scenarios. The ST-33Q can produce up to 5 watts of output power when running off alkaline batteries, and up to 10 watts when connected to an AC power source with the optional power adapter. In the next few minutes, we'll show you how to set up the transmitter, operate its features, and use it to energize buried utilities. In this segment, we'll show you how to install the batteries, how to get the transmitter ready to use, and how to operate its controls. The transmitter has 2 battery compartments, one in each foot. Remove the battery covers and install 3 batteries in each compartment with the positive end of the batteries facing out. You can use either alkaline or rechargeable batteries, but to prevent damage to the unit, never mix rechargeable and standard batteries. The batteries are installed, so let's power it up and take a look at the operating screen. The power key is located on the bottom right side of the keypad. We'll press it, and the SeekTech splash screen will appear, followed by the active frequency, and then the operating screen. The operating screen has several indicator icons and numeric readouts, so let's take a quick look at them. In the middle of the screen, you'll find the mode display scene. The graphic depicts a transmitter with one lead connected to a utility and the other to a ground stake. This tells you that you're in direct connect mode. If you want to switch to inductive mode, press the inductive mode key at the top left of the keypad. When you do, the transmitter will switch to inductive mode, and the scene will change to depict a transmitter radiating its signal into the ground. To get back to direct connect mode, just press the mode key again. If you plug in the optional inductive clamp, the transmitter will automatically switch to clamp mode, and the scene will show a transmitter with a clamp attached. When we unplug the clamp, the transmitter will automatically switch back to our previous operating mode. At the top right of the screen, you'll find the frequency indicator. To select a different frequency, press the frequency key located at the bottom left of the keypad until you cycle through and get to the frequency you want. You can program the ST-33Q with custom frequencies for compatibility with other manufacturers' receivers. If you've added a custom frequency, it will have a plus sign next to it to remind you that it's not a standard SeekTech frequency and may not work with your RIDGID receiver. For details on setting up and using custom frequencies, refer to your operator's manual. Next, let's take a look at the current level indicator, which you'll find at the top of the screen. This number tells you how many milliamps of current the transmitter is putting out. To increase the transmitter's output, press the up key. To decrease its output, press the down key. Let's press the up key and freeze the display. Right after you press the up or down keys, a number appears in the center of the display. This number indicates the target current output, or the amount of current the transmitter will try to put on the line. If the impedance of your circuit is too high, or if the batteries are weak, the transmitter may not be able to reach the target output. So refer to the numeric current indicator at the top of the screen to see what the actual output is. The graphic current indicator near the bottom of the screen gives you a quick way to compare the target output versus the actual output. The number of boxes indicates the target output, and the number of boxes that are filled in tells you the actual output. The final 2 icons are the battery level and audio indicators. When the audio icon is displayed as it is here, the transmitter will give you audible feedback. You can turn the audio off if you prefer, and the operator's manual describes how to do that. The battery indicator tells you how much power is left in your batteries. 3 bars means the batteries are full, and 1 bar means they're getting low. The transmitter has a number of settings that can be customized to suit your needs, and you can get to them by pressing the menu key. To navigate through the menu, press the up key to scroll up and the down key to scroll down. The top part of the menu contains a list of frequencies that are available for use. Each frequency has a box next to it. If the box is checked, the frequency is activated or enabled, which means it will appear when you press the frequency key to choose your locating frequency. If its box is unchecked, it won't appear when you press the frequency key. We can activate frequencies we use often and deactivate the ones we don't simply by pressing the select key to check or uncheck their boxes. We'll uncheck everything but 8 and 33 kHz, then press the menu key to close the main menu. Now when we press the frequency key, these are the only 2 frequencies available. If we want to get the other frequencies back, we'll need to go back into the main menu and check their boxes. It's important to note that when you activate or deactivate frequencies, your choices apply to whatever operating mode you're in at the time and only that mode. This gives you the convenience of having a different set of frequencies for direct connect, inductive, and clamp operating modes. If we scroll down a bit, we'll find the Tools and Information menus, which contain advanced options such as adding custom frequencies, adjusting the transmitter's maximum power output, and restoring its factory default settings. Refer to your operator's manual for a complete description of these features and instructions on how to use them. In this segment, we'll demonstrate the 3 ways that the ST-33Q transmitter can apply a locating signal to a buried utility: conductively, with its direct connect leads; inductively, with its built-in coil antenna; and inductively with the optional clamp. In our first example, we'll demonstrate the direct connect method of applying a signal to a line. This method of energizing a utility line has just 3 steps. Create the circuit, select a frequency, and set the power output. To create the circuit, we'll connect one of the leads to a ground stake, which you can find in its holder on the transmitter's case. We'll drive the stake in as far as possible, and then connect one of the transmitter's leads to it. We recommend always connecting to the ground first as a safety precaution, in case the line you're connecting to is carrying a dangerous voltage. Next, we'll connect the other lead to our target utility. If the connection point has paint or corrosion on it, you'll want to scrape it clean first so that your connection makes good contact. Our connections have been made, so we'll press the power key to turn the transmitter on. When the operating screen appears, we'll select a frequency, in this case 8 kHz. The current output defaults to 100 milliamps, which is plenty for this line, and the current indicator shows that's exactly what we're getting. So at this point, we could go ahead and locate the utility. Next, we'll demonstrate how to energize a line inductively using the transmitter's built-in coil antenna. In inductive mode, the transmitter generates a signal that penetrates the ground and gets onto any metallic lines in the area. To set up for an inductive locate, we'll turn the transmitter on and set it to inductive mode. We'll set our frequency to either 8 or 33 kHz, set our desired current output, and position the transmitter in line with the suspected path of the buried utility, making sure that the arrows on the transmitter point down the length of the utility's path. When using the transmitter inductively, its signal radiates in all directions. A portion penetrates the ground and energizes our utility, but part of the signal also radiates out through the air, and if you're too close to the transmitter, it can overpower the signal on the energized utility. This is called air coupling, and it can prevent us from getting an accurate locate. To minimize air coupling, we'll need to begin our locate some distance away from the transmitter, and we'll need to test for it before marking the line. We can do that by positioning ourselves over the target line and looking at our signal and depth readings. If the depth is completely out of range for the utility, it's a strong indication that you're air coupled. If the depth seems to be in a reasonable range, we can test for air coupling by raising the receiver a foot or so. If the depth reading increases by a foot, we're probably okay. But as you can see, in this case, it increases by far more. Let's look at this again, but this time focus on the signal strength reading. It should decrease significantly when we raise the receiver. In this case, it does decrease some, but not as much as we'd expect. So I'll move farther away from the transmitter and try again. Notice the depth reading. It's decreased significantly from the 3-foot reading we got before. This often happens when you move out of air coupling range. We'll raise the receiver by a foot, and as you can see, the depth increases by the same amount. Now take a look at the signal strength. As we lower the receiver, it increases significantly. These two readings are a good indication that we're no longer air coupled and can get an accurate locate. When energizing inductively, the signal tends to transfer onto all metallic conductors in the area, including nearby non-target utilities. The signal radiating from these non-target utilities can make it difficult or impossible to accurately locate the target utility. Here's a tip that can help you avoid this situation. If you know the location of the non-target utility, you can deploy the kickstand on the back of the transmitter. This lets you tilt the transmitter at a 45-degree angle, and with careful positioning, aim it so that the majority of the signal gets onto the target utility and avoids adjacent non-target utilities. The final method we'll demonstrate is energizing a line with the inductive clamp. The clamp lets you induce a signal onto a conductor when you can't connect to it directly. To use the clamp, remove the rubber plug just below the transmitter's keypad and plug the clamp into the 1/4-inch phone connector. Place the clamp's jaws around the target conductor, turn the power on, and select the frequency you want. In most cases, frequencies above 8 kHz work best, though you can try a lower frequency if you like. We'll set our desired current output, and as a final check, we'll make sure both of the clamp's LEDs are lit. When both are lit, the clamp is receiving the transmitter signal and its jaws are fully closed. In the past few minutes, we've introduced you to the ST-33Q transmitter. Before using the equipment, be sure to read the operator's manual for detailed information on the equipment's features and operation. And take advantage of the multimedia training modules on the support CD that came with your unit. The modules give you an in-depth look at topics such as circuits, frequencies, induction, and grounding, so you can get the most out of your equipment. On behalf of everyone at RIDGID SeekTech, thank you for buying the ST-33Q transmitter, and thank you for watching this video.